Hello everybody. Today I wanted to explore this website called Polyup, which is touting itself to be a kindergarten or first grade through 8th grade math tool, but having used it a few times, it looked like it might be interactive enough that you could build some games. I think I saw example machine in here that was implementing Flappy Bird. I'm not sure where it was. I'm just trying to pop out the chat here. Oh, here it is, Flappy Bird. So the way this works, there are some 3D objects in this game world. You can see the X and Y and Z axes here, and each of the objects has these chips attached to them. And the chips are built using a stack machine, which is a type of computer. It's a type of programming language. It's a type of programming language that's a little bit different from what you'd find in something like Scratch or Python or Java. If you have ever used a reverse Polish notation calculator, this is exactly the same thing as that. And I'm not too familiar with all of these different functions, so I will just be kind of walking through and learning them. This seems to be a memory block. So this is like a function, and it reads any one block followed by a model block. It stores a copy of the first block in the indicated memory slot of the model. So looks like there's a few different possibilities here. So here, this looks like an assignment, a variable assignment. So this is saying triangle, or no, the triangle attribute of the poly object. There's poly objects probably referring to one of the models here. This guy here is poly. This is saying, we can go back into the demo. One thing I wish is that these scene transitions were a little bit faster. Feel like navigating in and out of the different parts of the game takes a long time. But if we go back to the demo here, the poly character that we saw in the 3D area has a triangle attribute to him, and when you stack up these blocks here, what it's saying is to take the triangle attribute of the poly character and hello, nice to see you here. Take the triangle attribute of the poly character and assign it the value 5. And then here it's probably reading that value back out. So this is a variable assignment, like you'd find like a equal operator in a normal program. In Scratch, this would be equivalent to like the set variable to some value, orange block, I think, and then this one would be the reporter block in Scratch that gets the value back out. Oh, we can actually run the demo. So here, yeah, that's setting the variable, and that should bring it back out 5. So this code here is setting this 0.2 value on this object, which in this case, I'm not sure if this is different from poly. Maybe it's setting it on this block here. There's the A button. Huh. That is interesting. Alright, and then this block here, oh, this is the engine. This is what's actually implementing the Flappy Bird game. So let me just try it out to make sure I know what's going on. Oops, I already died. Right, here's the A button. Oh, this is very hard. Okay, so when we hit A, this guy flies up in the air. So let's try to see what's going on in there. So what we have is saying collide ground followed by apply velocity followed by apply gravity. So these are different functions here: collide ground, apply velocity, apply gravity, and then there's some other helper function called the dice5 here, and there's an empty one called dice6, which I don't know why that's there. Dice5 is used over here. So collide ground is first. I guess we could try running this. Oh, actually it runs from the top. I forgot about that. So apply gravity is first. So it's saying this is, so it's getting the triangle attribute out, which in the other code that we're looking at was stored 0.2. And then what's it doing? It's subtracting 0.015 from that. So it's subtracting the small amount from something that got it, some number that got initialized. Then it's gonna store it back on the triangle attribute. So the triangle attribute means something, and every time this runs, the triangle attribute is getting a small little bit taken off here, and that's called apply gravity. Oh, and here we go. So here we're reading out the triangle attribute and moving up. So the triangle attribute, every time you press A, this is getting subtracted by some small amount, and then moving up by the amount in triangle. So this is moving up, moves up by that many units. So this is where the jump is happening here. And then finally it does this thing here where it says if, what does if do? It reads 1 boolean and 2 data blocks. It's saying if this less than is true, let's look at the example. If this greater than thing is true, then so here it's saying if 1 is greater than 2, then it'll give us this 2 dice value, which is 7. So if this is right, this should give us 7. 1 is, oh, not greater than true, so it'll give us 3, which is, I guess, 30. Okay. So this thing here then is saying if this whole thing is less than, then it'll give us 5, otherwise it'll give us null. 5 and null. So what is this doing? This is saying, what if we can just run the whole thing and slow it down? Oh, that triangle value started at 0. That was not what I was expecting. Oh, this is probably because I'm just running this code separately as opposed to running the whole script. So the other block didn't run and it didn't get initialized. So it's subtracting a small amount from it. Now it's negative. That's reading it back out. It'll be some small negative number. And then it'll move up a little bit, or down, I guess. So that's how it falls. And then here it's saying this, oops, I just stopped that. This get position. This is creating 3 number blocks, X, Y, and Z. Okay, so read out its current position, store it in these 3 variables, X, Y, and Z, and then If z, oh I see, and that throws away x and y, and if z is less than 0, then you've died, I think, is probably, or maybe if z is less than 0, then you're still alive. And in one case it's doing this 5 block. So here, reading out this triangle, which I'm pretty sure is velocity, multiplying by negative 0.25. That, not exactly sure what that does yet. And then storing that back in the triangle, minus 2.5, that's interesting. And then here we are saying x and y. Oh, we stored, okay, so we stored x and y from the get position earlier. So here we're just saying set my position to x, y, and x, y, and 0. We actually have to run this to understand what it's doing. Speed this up since we already went through this part. They're getting the current position. Z is 0.3, y is -1, x is 0.03, and then z, comparing z with 0. Okay, this is the death check to see if you've hit the ground. So that is false, and so we'll do null over here. Huh, okay. So the A, oh, now I understand what's going on. So over here in this A chips, this is what's happening every time you press the A button. And that is just saying, whatever the velocity was before, I don't really care anymore, because now I just want it to be 0.2. So this is what causes you to start flying up into the air again, and then that gets and then in the engine chip, that's what's implementing the physics. Whoops. Right, so every time you hit A, the triangle variable gets set to 0.2, and then in here, if you're not doing anything over and over and over again, you'll subtract 0.015 from it over and over again. And then this, maybe this is what happens when you die. It'll move you to a certain spot, possibly. And that's why you're multiplying by -0.25 here, maybe? Not exactly sure. Let's see what happens when we die. Which should be pretty easy. Maybe it moved, maybe what happened is it moved the character off camera somewhere? Actually, I'm not even sure. Maybe that's not where the death is happening. There's another engine chip over here. Maybe this is doing the it's probably doing the pipes. Yeah, here's the pipes. So here we have, oh, yeah, this is a very powerful language. It should actually be possible to do all kinds of things in here, but it may take a while to understand. I do not have Discord, but should I create one? I just logged into Discord for roughly the first time ever the other day, so I'm not really that familiar with using it. Used other chat systems in the past, but haven't really played with Discord much. I can create one if there might be interest in it. Alright, I'll look into that. Let's see. We have all these cylinders. So fold's actually like a really powerful function It's funny that they call it functor here. That is very nerdy. What does the page say? I'm curious. Oh, they have so much power in this. It's it seems like it's pretty like there's so many things they could do in Polyup that are not first grade to 8th grade math things. But I guess that's where their market is right now. So what the fold block does is it takes it takes a list. So the first data block is the list for each block B in the first data block. It runs the second data block using B as an input. So it takes your list and then takes another function and shoves each item in the first list into this function here. Am I on my laptop? Yeah, I am. Is that can you hear the laptop fan or something? So the function, the fold function, this is actually common in a lot of programming languages. Sometimes it's called reduce. And actually, as you get to have like larger and larger programs that you know, like even like YouTube, you can't possibly run YouTube on a single computer. So what Google does is this approach to programming called MapReduce, and to reduce in MapReduce is actually just the same thing as what this fold is saying. And then so it takes this list as an input, and then it runs another function on each element in the list, and then it returns a list of all the outputs. So it's a powerful way to combine functions into to be able to run a function on everything in a list without that much code. You just call fold once and pass the function into fold. So here, what is this doing? This is moving pipes. It's saying taking all the pipes, which is this thing here. It looks like there's 10 cylinders that are in various spots, and these are just referring to, if we go back to the field over here, there's these 10 cylinders here. So this is probably like, yeah, this is cylinder 4, has a position, rotation, and a size. Yeah, so they just created 10 separate cylinders here. And then hello, yeah, hello everyone. We did 10 separate cylinders. So this is your list of pipes here, and then you have this move pipe, which is this one, and this is like a parameter. This is like an input to a function. If you're familiar with Scratch, it's like the parameters in your pink make your own blocks. This one's called A. And so move pipe is going to do, it's going to have some input A, which I guess is this is the actual cylinder. So each of these cylinders can get passed in here. That's what this fold is doing. It's saying take each one of these cylinders and shove it in here in a parameter, and then run this function, and whatever this function outputs, then it'll be left behind as a new list. So 0.05. Hey, nice to see you. Thank you for joining. So here's A saying move right. What's move right do? Move right is reads a number and a model. So the model block's probably coming in as A. So here's the number and here's the model. So it's saying take whatever the cylinder is and move it right by 0.05. So this is what's making the pipes move the right? I thought they're moving to the left. And then, what does this one say? Check position on A. This is a cylinder again. So check position is now saying it's taking in the cylinder again. Get position, that dumps it in X, Y, and Z variables. And then it says is Y less than -5. If it is less than -5, reset position. So this is going to move left. Hello. Welcome. This is going to move left. Move left a. So move the cylinder 10. So every time we call this fold, then pipe will be moving 0.05 to the right, but when the Y position of pipe is less than -5, then it moves left by 10. I'm not going to read your username out, but it's funny. And then so this is what will jump. Let's see, if Y is less than -5, then that will be what jumps it back to 10, wherever that is. And then we have this thing, check collision. Oh, that's at the very end here. So after we check position, we might have jumped all the way to the right already. Then we'll check collision over here. So that will be, again, it's taking the cylinder. Huh, that's interesting. I'm a little bit surprised that this parameter over here is readable in this stack. It seems kind of unusual. Anyway, but it's taking presumably the cylinder model again, and then get distance. Okay, so it's taking the distance to Poly, that's our main character, and saying if that's less than 1, then you lose. So lose, oh, here we go. Lose sets the position of Poly to this crazy far off distance, 10,000 XYZ. That's why you can't see him anymore, or her, or it. So if the distance between Poly and any of the cylinders is less than 1, then you lose, otherwise do nothing. So it's actually the cylinders that are moving to the left, and then they jump over here, which I guess this must be 10. So there was something I saw in here earlier, which is like a camera that I wanted to play around with and see how that worked. That is... I can't see your messages. So feel free to ask me any questions and I'll be able to see them. There's a camera, so let's see. I don't know how to... No, that's create machine. No, that is searching all the... I have no idea how to add anything to this level. I wonder if I'm actually editing it. Oh, maybe I need to clone it. It's probably owned by someone else right now. Polyup is another programming language, and their website says that they're for 1st grade through 8th grade math, but it's actually way more powerful. I mean, oops, I'm not very good at this game. As you can see here, you can implement some games in it, which I can't demonstrate because I am terrible. There we go. And we're just looking through, if you want to rewind the video at some point later on, you can. We're looking through the code and trying to understand how this worked. There's 10 cylinders here and they're just moving, and when they reach a certain point they just jump back over to the right. I probably need to copy this somehow. Here, clone machine. Let's like remix. So here, and here's our tools. So I remember seeing this camera earlier. I was curious to see if I could get this to work. I get hard to tell where I am in this world, or what the position of this thing is. Rotate it maybe? There, now it's pointing towards the cylinders here. I don't know if it's gonna work. Whoa! Alright, that's sideways. Can I even see Poly? Nope. Move it this way a little bit. I don't understand something about how this works. I guess maybe this is the top? Oh, that's better. Oh, kind of attractive. Ooh. Sort of a dramatic point of view. It does look like there's a ground, like I can't see... Can I see down through the ground? I don't think so. Bring it up a little bit. There, it's like a better view. So it does seem like it should be possible to create games in here. I don't have the best idea of what to do. Maybe if you have an idea of a game that you think would be fun to make in this, you can leave it in the chat or in a comment. And we could look through that later. So I guess there's two separate people with similar name and profile photo. And they're chatting at each other. There were some other games that I saw that'd be interesting to look at. I don't remember where I found them. Home. Any other machines? Crossy Road. I think so. I don't think I'll be able to do it quickly, but it seems like it should be possible. Try playing around with it and see how far we could get. Probably won't be very far in one session. I actually haven't played Crossy Road before. Sort of know the general idea. I look for screenshots. This looks like the old game Frogger. There's like blocks and things. You could have like a character and things going across. Cars. We'd start with the cars. You're here to grant one wish. I might be able to do something with cars. I have no idea how to create a new machine. Here, create machine. Let's see. we can have, I need to figure out which way is X, Y, and Z. So right now, this is like the poly character is at minus 4x. Does that mean this is plus 4x? Yeah, 3x. So the red line is x. Let's move him up, or her up. That is z. So the blue line is z, oddly, and then the green line must be y. It's not totally not where I think it is. Oh, Control Z doesn't work. I just rotated. There. That is... Hello! Hello everyone who's watching. So let's just double check that. This is Y. So we have X is red, but this is strangely negative X, I think. And then this is so confusing. Everything seems backwards. This over here is positive Y. So actually this is really the way to look at it, is with, yeah, that's positive X. And that's positive Y. And then blue is Z, and is this positive Z? Yes. Okay, so I think the mnemonic they're using is red, green, blue is XYZ. Red, green, blue are X, Y, and Z, and then the direction the arrows are pointing is plus. Does that work? Oh, yeah, so they're all... Okay, yeah, that kind of makes sense. So, hello on the chat. So what we would want is, where's the camera? Camera is just by default wherever you put it. Okay. So if we put a camera, we could put the camera, I guess, up above to start and pointing down. We'd want it kind of facing this way. I get a lot. Really hard to aim. Oh, totally not where I thought it was. We'll set this guy. This will be 0. There's probably some engine turtle. I guess turtle will get called when the program starts, maybe. Let's see if that works. We'll attach some code to it and try that. I don't know where anything is. Here, look, a bunch of functions in here. Set position. Set position 2, and there's probably X, Y, and Z. So we'll do x and y will be 0. And then z will be some number. 9. That'll work. Thanks. X. I don't actually know what's going on. Let's try. Get rid of it. No, the position didn't update. I'm actually very confused. Oh, the camera's very hard to position this. I just have to just always constantly rotate it around and use these arrow handles. There we go, those are close to 0. So now, there we go. Now we're looking at it from above. Then, I mean, we probably want this guy to be our main character. So we'll have, maybe we'll have him point. Maybe this, I wonder if this turtle block is like when the program first starts running. Let's try setting position in here. Set position to 0, 0, and 0. That didn't work. It didn't move at all. Which is odd, because this one was working. Didn't that do anything? Well, don't do that. I'm moving to, we'll move forward, maybe like move forward 5 or something, to see if this code's even working at all. Oh, it did move. It did move, but the set position didn't do anything. I see. Maybe there's another block over here that moves. Moves it. We try get position and see what it says. Or as a model block as input. I saw something called this. What is poly? Alright, so oops. I got rid of that. Text is so small. Okay, get position there, then we'll try setting the position, and then we'll try get the position again to see if it worked, and we're gonna need to pass this parameter in. Alright. So initially, oh thanks! So initially, oops. Initially, get position has these numbers, 3 and something, then we set position. Oh! Oh, that's the problem. Oh, there's a typo. Well, I don't know how far I'm getting. Set position operator requires 3 number blocks and there's a typo here as an input, but it probably needs to set the position on a block. That's probably why it didn't work earlier. So I'm gonna just try to test this. There it is. It's at 0, 0. That's moving to the right. So we actually want it to point. Probably want it to point in the plus y direction. That would be, I think, the easiest way to think about it. You'll want to rotate. I wonder if there's like shift or control or something. No, alt. No. There. Is that exactly 90 degrees? The rotation we want 0, 0, minus 90. Okay, that is 2. 0, 0. We don't actually need this code anymore. And we don't need this code anymore. And, ooh, I guess we can leave that in. Make sure it's pointing in the right direction. But we do want to rotate. Here, get rotations. I'm trying to see. Set rotation here of poly to, what did I say? I already forgot. 0, 0, 90? 0, 0, minus 90? 0, 0, minus 90. Oh, that's moving the wrong way. That's backwards. So maybe this needs to be plus 90? We can try that. There we go. Alright, now I do think that there's these input buttons. I don't know if Crossy Road has like a, does it have like a jump? I have no idea how it works. It probably has a left and a right. See what these are. Stack these on there. That looks like a up. Put that up. Does one person have so many different profiles? Here, oh, this is down arrow. I'll put that on the back. Hard to check these things. A little space here to attach these. I wonder if we can make these. Ah, I didn't mean to click that. So for down arrow, maybe we can try to have it move back. Move. What's the difference between these two? I wonder if it's the same thing, but one of them's a picture. Move back operator reads a number block and a model block. Compared to this thing. Oh, okay, so this guy here, the picture one, will just take a single number. So we could add just a number, 5 or something. Compared to this move back block, what it says is, oh, the program's actually just, it's a free website called Polyup. Their website is branded for 1st grade through 8th grade math problems, but it's actually a pretty full-fledged programming language. So you can just go to polyup.com. This there's no game yet per se that I'm working on. But I guess you could, I don't know if this is public yet. You could try typing in that URL, I guess. I'll paste it in case it works. Yeah, so the move black block, what it's saying is different, is you have to pass in this which thing you're moving. So I guess in some ways that's much more powerful, because you could get one of your objects in your 3D world could actually move a different object. That would actually get very confusing though, so my guess is it's probably a bad idea to do this, where you're actually moving a different object, because then you have no idea where the code is. That's like if you have like 100 objects and they're all moving each other, you have no idea where the code is. You can't possibly find it after that. So since we're just moving here, down arrow will move back by 5, and we can see what that does. So let's start, and then I'll hit, oh, okay, that was a lot more than I was expecting. Let's try a smaller number, I guess. There we go. Okay, that seems pretty good. I am guessing that we don't actually want the character to move forward on its own, so let's get rid of that. This turtle will just be the initialization code. And then we're also going to need to move forward. Here, yeah, up arrow. So this will say move forward by 1. Oh, I see. It depends how long you're holding the button down. So the reason it moved back so quickly before was because I held the back button down too long. So the issue with this is we probably want it to jump forward and backward in steps of of 1. We'll need to do something called debouncing this. No, I guess this is... We need to get one mouse click to be treated as a single mouse click. Wonder if they have something like that already. So if every time, I guess there's a tight loop, and every time up arrow is down, it will do this thing. So we need some kind of notion of time, maybe? What does this do? Get time block. Oh, it's like the timer block in Scratch. That seems useful. Up trail, get distance, get scale. Oh, there's this block over here. So I guess the reason that Flappy Bird worked was because even though you might be holding down the A button, it wasn't actually moving. It wasn't actually directly moving anything at the time. It was actually just setting a variable. And so as long as you're holding the A button up, we can actually check that. I think that as long as you're actually holding the A button up, it would just continuously keep that same velocity. Let's try it. Oh, no, that's up, not A. No. I wonder if the A button works differently than the arrow keys. That may be the case. So let's say we got an A button. Is this the A button? I can. This way. If we got the A button to move, maybe this will be moved by 1. Maybe this will be more discrete. So instead of pressing up, oh, there we go. Yeah, so the A button and the B button are one click at a time. I guess a quick thing that we could do is say A moves forward and B moves back. That's B. The poly character is getting covered with these barnacle chips. Move back. Move back. So we'll say A and B. There we go. And then we could add left and right. And I guess for left and right, it's a little bit less important that it be exact jumps. Ugh, so hard. Can't even click on it. Let's move it. Get rid of this block. I don't think it's very interesting. What is this one doing? Just moving. A little demo. So you can throw it in the trash. There we go. This guy is all covered with chips. Oh, if you zoom in, it's a little bit easier to grab these things. So A is forward, and then we'll have a left. Left? I'm actually thinking it might not be a good idea to cover every single surface. Oh, there, we can put diagonally. That's kind of funny. This is the left arrow, so the left arrow will take the move left, and we'll move by. One was kind of fast. I'm thinking of trying something smaller. Point 1 maybe? Oh, and this would be a good spot for a variable. So instead of saying 0.1, we'll have, I wish you could name these things. We'll need to remember which of these shapes means which thing. Well, Flappy Bird was using triangle for velocity, so we could use triangle here. And this takes a model block. So we'll add this. Let's say, get me the triangle of this. And that's how much we'll move to the left. But we'll need to set the triangle variable of this. I think we can do that in here. We can say, what can we call this? Init velocity. And that will get called there. And it'll set wait, is this set or read? Get. We want to set this triangle to 0.1. Is this gonna work? Yeah, that looked good. And then we also need the right arrow, which maybe we can also put that in a funny jaunty angle over here. And that will do the same thing. We're going to move right. We're going to move right by triangle of this. Let's see if that works. Maybe we need to run the whole thing because the turtle block didn't run. Let's see, so A and B still work, and left and right work too. Okay, so I think we need cars. I remember seeing cars in the screenshot, so it's an easy way to make cars. We could have, there's a way to make this bigger. With a cube and a cylinder, sphere. We have rolling balls. Ooh, that's huge. I guess let's get rid of the up arrow and the down arrow, because those are just going to be confusing. On the arrow. Double check that that still works. A, B, left and right. We need a bunch of these cars, so I wonder if there's a clone function or some way to create more objects. Figure that out. click on that engine, because that seemed to be running continuously. And then somewhere, no, maybe there's no way to make new models in the 3D world. That's probably why that Flappy Bird game had so many copies of the cylinder. And we need to just do the same thing here, where we have of balls. We don't want to copy the same chip onto all the balls. That's probably why there's that function that lets you move other objects, because then you can have kind of one game engine. So it'd be like one kind of master truck engine object, which I guess kind of needs to be like a decorative background object somehow. I don't really even see what these are. Make like a change the color or something like that. Well, just for now, this can be the engine. So this will be the thing that's driving the spheres to move around. Engine blocks. Can we rename this? Oh, here, edit here. Oh, this will be the sphere rolling engine. Sphere rolling. The sphere engine. And oh, what does moddable mean? Huh. Oh, this probably means you can edit the code during the game. Let's try it. No, we can't see chip though. I'll have to, I don't know where to get help on that. Turn it off for now. So here in the engine, we'll use that same fold technique. So we'll say, what do you want to do? I want to have a list of all the, this is all the spheres. And that will be one of them, and I'll make a bunch of them. Chip, we don't want to have a chip on it. I'll just put a bunch of these in here. sphere 1, sphere 2. I think it really matters what order they're in. Then we will have to have them come in from the left. So this engine's going to be running continuously. Like it'll call this function, the poly function, over and over and over again. So we'll have to fold a new function, which will be doing the physics. So we'll have to, what will each of the spheres have to do? They'll have to jump over to one side of the screen, some random amount, and then move. So we'll say, let's just call this tick. The fold runs. The first block is the data block, and the second block is the function. So we'll fold the tick function over spheres. Is that how this works? I guess I could try it. What could we call on each of the spheres? Make sure that A is the sphere, and we want to, oh well, we actually have them just move, so we'll have them move left. But in this case we'll need this move left block, because we'll need to tell it to move A to the left by some amount. That work? Oh, one of them is moving. Alright, that was not the right way to refer to the list. It got expanded into a whole bunch of things. Maybe it's one of these. That, and then maybe this actually needs to be... Oh, so these yellow blocks are like a pointer to the function. So if you use this version, wait, where'd it go? Like if you drag this, it'll just call the function immediately. But if you have this yellow block, it'll be like a reference to the function. And so this way, these two things will get passed into fold, and then it'll go and look at them. Let me see if that works. Yeah, that makes more sense. So now it's calling tick on the first sphere 5. And then, oh, there's like an accumulator here. See, there's this 2 that's turning into a 3. This is keeping track of where it is in the list. This is like your loop iterator. Alright, so this probably should get all the spheres to move. There they go. They must not be pointing. They must not be pointing the direction I thought they were. And if that was their left, that's their left, so this must be their up. So this would be back. Let's try having them move back so they're coming in from the right side. Very odd. I feel like it's a very odd default set of orientations. I'm sure there's a reason for it, but it seems like very different from kind of like standard conventions that are taught in math. I'm just a little bit confused. Ooh, that one went flying up in the air. I guess we need to just kind of orient all of them. I guess we just want to orient them and then have them move forward. I said I can't tell which way is forward. I guess we're not using the up arrow anymore, so I can attach the up arrow to one of these and have that move it forward just a little bit, and then use that to debug which direction it's pointing. I'm very confused right now, so we'll hit start and then we'll need to turn that engine chip off actually. Make like an empty list, this will be called. Empty list. There's probably some better way to do this, but for here we'll just pass in null. Maybe that'll work. Alright, now we'll hit up. That is, I think, moving the way I imagined it to. Let's see, what is this doing again? This is moving forward. So this guy is pointing towards the right side of the camera right now, which is 0, 0, 0. And if I rotate it, to point the other direction like this, then that's considered to be 0, 0, 180. And from there, if we hit up, then it's moving from right to left. Okay. So we could say, I wonder if we can do this in the engine block. We could say, well, we don't want to do this every time step. We actually only want to do this once. So maybe we'll put a turtle lock on here too. The problem with this is it's going to cause two. I'm trying to figure out how to get there to only be one list of spheres. I wonder if we can store a list inside of a variable. So we'll say this. I don't want to use a triangle. That means velocity now. Set the list. What's going to be the list? The square. It's very confusing. Square. Set the square of this to be, and this will be all the spheres, be like that. And then we need to drag all of the spheres in there. Sphere 1, 2, sphere 3, 4, 5. And then first let's check that that even works. No, set memory operator cannot set a state variable to a data block or a function. Well, that's unfortunate. Let's just get rid of this turtle block. So here, I guess what we could do is in tick, we could just orient them. I don't really want to run this code every time. Let's call it rotate. But that seems like it'll be simpler. Tick will rotate. We'll rotate A. A is the particular sphere that we're acting on. And that rotation will be 0, 0, 180, I think. What's that rotation? Rotation, it'll be 0, 0, and 180. And I think set rotation needs a model block. We need to say, oh, not this, it's actually going to be a parameter A. We'll rotate whatever's being passed in to 0, 0, 180. And then move forward, because now we're pointing right to left. We're pointing towards the left in the camera. Okay, let's see if that worked. It still works. None of them are moving though, because we disconnected the fold. Oops. Here. Tick needs to run against spheres. Try that. Oh, they're moving to the left, except for that guy. What's that guy doing? That guy's doing some weird thing. Oh, because he has his own... that shouldn't matter. I wasn't pressing up. We can get rid of it anyway, but... try to get rid of it. Oh! I can't grab it. Oh no! It's not letting me grab this thing. There we go. So one of these is like a rogue sphere that's going the wrong way. Even though I thought I oriented all of these. Oh, are these connected to each other? What's going on? Right. and red. Oh, that one's pointed opposite. This one's pointed in a weird direction. Maybe this one's the culprit. I'm rotating it, so it's pointing the same way as these other guys. Yeah, let's move this one over there. It's different. And you are also different. Move you over here and see what happens. That's not the perspective that I was expecting. Oh right, that's because this is actually down. Let's move you over here and you over here. Oh, they're all moving the same way. I wonder if this camera has some settings. Not really. It's just kind of like a weird perspective. I wonder if it needs to be further away. No, not. It's so hard to aim. Alright, so the blue arrow. Blue arrow. Dragging it up. Oh! That's a little bit better for perspective. Although a little bit too far away, I think. What's its position now? So it's basically at 0023. I think it should also be possible to put an engine on here and have it move around too, which will probably be necessary to make the game look cool later on. But for now we could use that to be set position of this to 0, 0, and I think I said 23. 23. Alright, now let's get these balls to jump over to the right, maybe. We're saying every tick we will move forward, rotate. I guess we should actually rotate first. Rotate first, then move. 0.1. And then rotate A. Move 0.1, move A by 0.1. And then we want to say if here we'll say if this will be the jump to the right, reset to right side. So this will say if, where's the if the position get position I can't remember what order those came in. Let's go look at this machine. Oh yeah, this engine block that controls these tubes is actually just over here and randomly on this. I can't click on it. There we go. So you can't position and then it's ZYX. So Z's on the bottom, that's why. ZYX. And then in our case we're moving oops. Maybe we should name it Crossy Poly. Oh, is there some kind of only people with the link? Everyone can see this machine. Oh, maybe the link that I posted on the chat will work now. Default camera shows the X, Y, and Z axis. Oh, that actually looks good. Oh, that's actually helpful. Oh, I wonder if we can get rid of the camera now, actually. We wouldn't be able to move the camera. We're moving in the negative x direction. If x is less than some amount, then we'll jump to some positive x number. So we'll say get position, z was first, and then y was second. X was on the top, and then we'll say if x is less than x is less than some amount, so like minus 20? I'm not exactly sure what the size of the axis is. So if x is less than minus 20, then we want to call this check fell off left. Check if it's too far to the left. Then we'll want to do jump to the right. I'll take a parameter, which will be the sphere that we're working on, and it will move I need to set position to whatever y and z are. We'll just want to leave those alone. But then x, we'll want to set to some positive number. Over here it said minus 20, so let's try 20. And then if that's true, then we'll want to jump to the right. The true is the top data block. And then false, if it's not there, then we'll just do nothing. It's null. Alright, let's see if that works. not clear. Did we actually call this check if left? No, so we did rotate, then move, then check. So I'm gonna check here. There. Let's try it now. Still not clear. Let's try a much smaller number. Like -1. Actually, there might be another way to debug this. So if we take one of these and we look at its x value, it's at -10. So I would think at -20 you'd get, okay, so these darker lines are 5. So this is -20. So all of these should be less than -1. So I wonder if our condition in here is reversed. If, oh, that's setting x, but we actually want the value of x. Nope, that didn't work. Actually, I think many of the spheres are already here. Let's just move them all over here. And now, I think we can just, oh, hello. Nice to see you here. Thanks for joining. This is so hard to read. So move, this is where I'm moving forward. Okay, that's fine. Just move it forward. And then here's the part with the problem. So I'm saying, what's the position? Oh, that is an issue. That is an issue because that block needs to know what it's getting the position of. So here we have check if too far left. We could do A. And then we could pass in A. Pass in A over here, and then we're going to get the position of A. Then we just check everything again. So the position variables will get saved in x, y, and z, and then we're checking if x is less than -1, and then if that's true, then we'll jump to the right, which is taking a parameter. Maybe this can't take. Let's try. No, it's still not working. Now getting position should work. Setting these variables. Alright, x is definitely less than -1. Should be true. Which then the if statement should be doing jump to the right. Which it did. Oh, set position also probably needs to know what we're setting the position of. Here. Here it'll be A, set position of A. Great. That should hopefully work. There we go. So switch that back to 20. What is this attached to? Oh, that's the camera. Let's switch this back to -20. And then we want the, over here we're setting the rotation. We should also probably set the, let's see, so we're moving X, we probably also set Y and Z. So Y is going to be 1, because that's one step forward from the beginning of the game. And then, let's call it set X and Y and Z. So Y is going to be 1. Position. We could just replace Y and Z over here, but that'll be, I think that'll be a little bit less reusable. We want to have each of these functions do only one thing. It'll make them easier to reuse later. So that position of the sphere that we're acting on, and we're going to set it to although this is causing a lot of code. So we'll have to get the location, maybe get the position of A, and then do the same thing we did before, or store it in X, Y, and Z. But then we'll reset the position to X will leave alone, and then Y and Z, Y will be, Z will be 0, that will be kind of flat on the ground, and Y will be 1. Let's see if that works. That did not work, because I did not call a function. That actually needs to be, we'll put it right after the rotate, and make sure we pass the parameter. Set YZ of there we go. And now I can kind of jump forward and jump back. This camera is too far away. Changing to 15. I'm just guessing. So we have forward and back, and then if this is touching, there is a distance function. I wonder if there's a way to draw text in here. I don't know. We could have this be the game over. Yes, cylinder. The cylinder is the game over sign. Sort of abstract. There must be some way to change the size without running code, but I have no idea how to do it. We edit this, or what if we do like 20? Oh, that works. This would be game over. And now it's actually easier to edit. So we'll put 0, 0. And then we'd actually want this far off to begin with. So drop a turtle chip on here and say that initially we'll move to set position of this to, oh, there's some set color blocks. That's helpful. So set position of this to something far away. And then I guess in the sphere engine, we could either put the code for detecting collisions between the character and the spheres in the character or in the engine that's driving the spheres. And I'm thinking that it will be better to put them in the engine because the engine already has the list of all the spheres, and really I don't want to have more than one copy of this list if I can help it. So we'll make another function in here. We'll call this detect game over, and maybe this engine chip will actually just be the engine for the entire game, and that's kind of like how you would want to use, that's kind of how you would want to use these move blocks that can move any of the objects in the game, because you just have this one central god object that moves everything else around. So say detect game over. I remember seeing there was a distance block. There it is. So this reads two model blocks. So one of them is going to be the sphere that we're looking at right now. The other one's going to be our main character, Poly. It takes the distance between A and Poly, and it creates a number equal to the distance between the centers of those models in world coordinates. So if that is, I don't know, less than 1, okay, Poly is about 1. We'll say if this distance, which is calculated with these 3 blocks here, is less than 1, then we'll do game over. Game over. Otherwise, we'll do nothing. So detect game over will happen after game over will happen after what's over here. That game over will happen after we check if it's too far. Oh, I need to pass a parameter into that. I keep double clicking on these chips, thinking that they'll open the screen, but they don't. It just opens and then closes that little dialogue. Maybe if someone from Polyup ever listens to this video, that might be something to think about changing, or user testing at least. So game over is going to need to pass in A, but this is actually not game over, detect game. Right, and then game over, that one will want to move the position of the game over block to 0, 0, 0. And that'll move it back into the camera. Alright, let's try this out. Everything's fine. Maybe we'll back up a little bit. And then we'll move up into the path of these sphere cars. Oh! That worked pretty well. Now, I think one thing that we need to do, oops, let me resize my window there. One thing we need to do is have the cars jump to a random location instead of just 20. And I'm wondering if there's a random number generator. Interesting, I don't see a random number generator. So one thing that programs do in this case is to take a number, multiply it by something, and then add something, and just keep doing that over and over again, and kind of looks random. So use this. I'm not going to remember which of these symbols means what. We can say like update random number, and this will maybe we'll use a star. So we'll say what's the current value of the star, and whatever that is we will multiply by, I don't know, a number, and then we will add some other number, and then we'll mod take the remainder when we divide it by, let's say, jumping over to 20 doesn't really work. I want to go a little bit further. Let's say like 40 to 80, or we can do 40 to 60. We'll mod 20, and then we'll add 20. So this will take the number and make it much bigger. This will add a bit to it, and then this will divide by 20 and take the remainder. So this will give a number somewhere between 0 and 19, and then we'll add 20 to it. So we'll end up with a number between 20 and 39. But we should actually add something bigger, add 40 to it. And then this will store it in the star variable for this. So every time we tick, maybe the very first thing we'll do is we'll update the random number. Then over here, when we jump to the right, instead of always doing 20, now we can take whatever's in that random number, this one, and use that. And let's see if that works. Let's do this thing again. so that all of the spheres need jumping, and try to debug this. Oh, could not variable star on object sphere engine. That is probably because it doesn't exist. Maybe we have to set some kind of initial value for it. And I guess it might make sense to just put some numbers that we know that it's random. This isn't really sphere engine anymore, it's actually a game engine. I'm trying to... Here, check 2 left. Oh, don't want to skip it. This is hard to control. Okay, here's where we'll jump to the right. $50. And then we'll set the position there. That should have been fine. Maybe this is too much. Maybe instead of 0 to 19, we'll do 10 here, and then for now let's move this back to 20 so that they're appearing on the screen. I'm going to separately look up some better constants for that random number generator because it didn't look like the ones I picked were very good. Double check that I'm doing this correctly. So normally do a, yeah, so you take the old value, x of n, multiply by a, which is called the multiplier, and add c, and then mod by m. So there's some different ones in here. Oh, here's one with a small modulus. Hard to see. The multiplier A increment C, MAC. Let's try this one. That's a small modulus. The multiplier is 8121. 8121, and then the increment is 28,411. And then the modulus is 134, 1, 3, 4, what is it? 4, 5. Alright, and then now we don't actually want to do this plus 20 in here anymore. So this is just going to do its thing, generating different pseudo-random numbers less than 134,456. And when we use it, that's when we'll want to convert it to what we want. So we'll say this will be the X target X location, target X loc, and it will take the random number as an input and mod by, so take the random number and then divide by, what do we say, 10? Divide by 10 and take the remainders. That converts it to something between 0 and 9, and then we'll add add 20. And then here, we actually, this code's definitely hard to read. We're setting the position, let's see, we're going to jump to the right here, and that's going to retrieve the random value, and then we'll want to pass it through target X. So we're getting the target X given this random value, and then Y and Z are just whatever they already are, and we'll set the position. So hopefully this will work better. Oh yeah, that looks like different pattern than before, at least. I don't understand. Oh, there's all of them. So I think to get a bigger spread, we do want to increase this 10. Let's have them spread out a little bit more. And then here we're checking for -1, so change that to, I think we said -20 before. And then here, instead of +20, which is not totally off screen, let's try +40. So now we have whatever the random number is, we're converting it to something between 0 and 19 and then adding 40. So that'll be 40 through 59. That happened to work out pretty well. Although that wasn't as spread out as I was hoping. But they're coming in different patterns now. Now if we go forward and we get hit by a car and the big cylinder comes and shows that the game's over. So that's kind of funny. I think I'll sign off here. So if you like this video, please subscribe to the channel and press the thumbs up button and leave some comments and share it with your friends. I'd really appreciate it. It would help out a lot. Thanks for watching and see you next time.